Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Today we're going to look into how to read tables. I know that whenever you see a Z table, it might look very daunting and intimidating at first, lots of numbers, lots of decimals, but once you understand what the table actually gives you, every probability question should also become a lot more mechanical and easier to get through. We're going to use the same example across 3 different videos because I also want to show you exactly how the information that we learned on the CDF translates into the tables to make your life also a little bit easier. So for this video and the next two, what you're going to see is we're going to solve this problem where we're going to assume that we have Z with a standard normal distribution 0, 1, and we want to find what is the probability that Z is bigger than 1.2. Now keep in mind, the reason why this is split into some smaller videos is because we are going to see slightly different tables from one another, and I want you to be able that whatever format table you're thrown at, you're very easily able to understand the information that it's been given to you so that you can very easily jump to the answer. But first of all, let's understand the exercise that we're doing. We're asked to find what's the probability that Z is bigger than 1.2. So just because they are asking us about probability, it means they are asking us about an area. So if we have our standard normal distribution graph written in here, 1.2, let's say it's around here, the area that they are asking us to find is actually this area right here. So something that is bigger than 1.2. Okay, this is the area we're interested in. Let's use now the information that we learned on the CDF, because the CDF was giving us the area that accumulates up to a certain point, to how exactly we are going to find, well, this is actually an area that is not accumulating, but it's what's left over. So this video will also serve a little bit as a reminder of all the properties that we know about probabilities as well, and also some nice key ideas that we have about or advantages more than ideas that we have for the standard normal distribution. Remember the cumulative density function, so the CDF was giving us everything that accumulates up until a certain number. So if we use that, and let's draw again our standard normal distribution bell-shaped curve. If this is 0 and let's say this is a number value u that I am looking at into my z-score axis, remember, then the CDF should tell me everything up until this point, okay? So in the exercise that we saw, if my u is equal to 1, then that probability, so f of 1, it's literally the probability that I am looking at a value that is smaller or equal to 1, okay? From now on, instead of calling it just as f, because we are dealing specifically with the standard normal distribution, we are going to use a very special Greek letter to indicate exactly this area, okay? So which means that from now on, when I'm writing this, I am referring to here the u. I don't need to write the u, but just 1, basically. So meaning everything smaller or equal to 1. This is a convention that it's used everywhere, so you being aware of it should be a plus and should make your life also easier. So that means that when you are actually asked to find the area of something that's on the other side, so not on the left side. So keep in mind, this is referring mostly to the left side, okay? Anything smaller, okay? Now, when we want to find something that is bigger, we're going to have to use the properties of the probability, which means that actually, if I want the probability of u being greater than, let's say this was the value of 1, 0.2 in this case, the exercise that we're doing. So then this is the entire area probability minus the black shaded area, right? In words, mathematically, that means that entire area probability, that means this is where all my possibilities are. So that set space is exactly 1. And then the black area, we already gave it a number, a name, which means that from now on, whenever I want the probability of something bigger than a certain value, I have to do 1 minus the number that I would be giving out of the CDF. So that whatever is accumulated out up until 1.2. Right now in this video, we're not going to get an actual number. We're just giving this expression because it's very crucial you understand this expression before we move to reading the numbers in the actual tables. So once again, just this on its own is everything that's been accumulated up until the 1.2. This is what normally the CDF should be giving you. However, for you to find areas that are maybe not just textbook definitions, you have to work out with the probabilities and the characteristics of probabilities. In this case, knowing that the entire area is 1, we just need 1 minus the black shaded area that we already know it's going to be given to us from the CDF information. Thanks for following this video, and I'll see you in the next video where we actually find a number for this computation through the tables.